Okay, so I'm going to do 8.3, number 42, but only parts C and B.
Okay.
So part A and B are graphing the function f of r. Oops, sorry, not f of r. How about r of theta is 1 minus sine theta, right?
Oh, that's enough.
So this is a cardioid. It's similar to the one I did the other day.
And there's the same one on the practice test.
And it's probably the same one on the practice test. So part C asks, at what point does the cardioid r is 1 minus sine theta intersect a circle of radius a half centered at the origin? So I want to know this thing meets, let's see, circle of radius a half centered at the origin.
Circle of radius 1/2 centered at the origin.
So I need to go outer radius of a half, make a circle, crappy circle, my bad. Oh gosh, it's getting even worse.
Anyway.
At any rate, what is the equation for such an object?
R equals 1/2. Yeah.
Oh, nice. That's easy, right?
Soups.
So I want to know, when does r equals 1 minus sine theta meet r equals a half?
Okay.
So what do?
You plug in a half with it. No.
Close. What's a half?
It's not.
A half is a radius, right?
Oh,
So that should go in over here for r.
Right.
So 1/2
So you should take 1/2 and set it equal to 1 minus sine theta.
sine for theta, solve for theta.
Oh, which is a nice example because this is what I'm supposed to teach you today anyway.
Wow. How convenient.
Solve for theta.
Math builds, right? In a pretty natural way. This happens all the time. Right? Because the hardest question in this section is going to basically be the start of the next question.
Right.
So-
So difficulty is just lack of knowledge.
Yeah. So to solve this, what do you do?
You
well.
divide by no.
Yeah, I would subtract
Subtract
1.
1,
I'd subtract 1
And then
too.
multiply by negative.
and then you're
So if
left.
you subtract 1 from both sides, you have minus a half is minus sine of theta.
So then multiply negative 1.
Multiply both sides by negative 1.
And take the
And then take the inverse.
sine.
So you got 1/2 is sine of theta.
And then inverse sine.
And then you should arc sine this thing.
It's 30.
So you'll
degrees.
get theta is the arc sine
1/2, which is a special
of
angle.
1/2.
Which is a nice standard angle, which is 30 degrees.
Okay, and that's a standard angle,
Yeah.
right? 30 degrees?
Mhm.
Yes?
Yes.
Okay, so theta is then pi over 6.
Mm-hmm.
How
Radians.
amazing.
Cool.
R is always in radians.
Okay.
Something else.
Hang on though, because this, right? Because there's supposed to be a cardioid, right?
Mm-hmm.
The cardioid looks like this thing.
Mm-hmm.
So it should hit it.
Is it the other way?
No, it's like basically,
Is it vertical?
it's the way you normally draw it. Like if you just drew a heart.
Oh, it's a heart just the other way. Okay, sorry. So this one's cosine, right? Sorry, I didn't do part A and B. I should have.
Would that be negative cosine? 'Cause it's the opposite direction. No, that was positive.
So you have some kind of heart like this, which probably intersects at least a couple of times,
Okay.
right? But I only found one.
So every coterminal.
That's just the only ones that arcsine contribute.
Yeah, this is the only one that arc sine gives you. So where's arc sine defined? Where's the range of arc
Negative
sine?
pi over 2
To negative pi over 2.
Yeah, it's from negative pi over 2 to pi over 2. So that's giving me angles on this side.
So we just do the reference angle on the other side?
Yeah, so I need the, it's not the reference angle on the other side, it's the,
It's the angle that gives you the reference angle of pi
yeah.
over 6.
I need the thing that, whose reference angle is
yeah.
pi over 6, right?
Right.
So, let's see, if this is pi over 6 on this side, then that one's probably going to be
Pi minus pi over 6.
pi minus pi over 6.
Which is 5 pi over 6. I don't know. Wait.
Okay. So, or 5 pi over 6.
Yeah, okay, so
Because pi is 6 pi over 6, right?
Right, exactly.
So if you have 6 pi over 6s and then someone takes one of them and runs off, then you have 5 pi over 6s left,
yeah, and if they're like that.
right?
Yeah.
Okay, but then this is still not quite right, because,
It's every single coterminal angle with those.
yeah, because then it's all the coterminals with those.
And what about the one whose reference angle is like underneath, so you go past pi?
Okay, so what about like this one down
Yeah,
here?
so pi plus pi over 6.
My claim would be that one down there isn't showing up because the one down here isn't showing up.
Oh, that makes sense.
Because that would be the reference angle of the one down there.
Yeah. I would have seen that with arcsine, basically.
Okay. I see.
Right? Because arcsine gives me something on the right half.
Right.
So if there had been something on the lower right, in the lower right quadrant, I would have got it with arcsine.
Okay.
I didn't see that one, so it wasn't it.
Signs are negative in those quadrants anyway.
Yeah, sine's negative in that
So
quadrant.
you wouldn't have been able to get a positive answer for.
Yeah, I definitely wouldn't have gotten a positive answer. A spot I could have gotten at is if I had had like a plus or minus half here. Right? Then I would have had at least a couple options. Let's go with that?
Uh-huh.
Okay, so I get these, or pi over 6 plus 2 pi, 5 pi over 6 plus 2 pi, or pi over 6 minus 2 pi, or 5 pi over 6 minus 2 pi, or...
Can you just say k, 2 by k or something?
Yeah, that's probably a really good idea, right? K's on both of these, where k is in the
Integers.
integers.
And those are bold.
Let's go with that. But they really just ask for where the points, right?
Yep.
So where are the points actually at?
Point is that when the is 5 or 6.
So the point is theta is pi over 6, and the radius is
1/2.
1/2. You see that? So this point here in polar is radius 1/2, angle pi over 6. And this point over here is radius 1/2, angle 5 pi over 6. So those are the 2 points in polar, right? So maybe I put little P's on those to remind you those are in polar. Okay. Graph the curve. Oh,
I didn't even know about that.
okay. So you could graph this other thing. It would be similar. I think it'll give you 2 cardioids overlaid. Should we do that?
It was a weird, like, this kind of thing.
It's possible that it would be 2 little funny things kissing.
Yeah, that's what it was.
I'd have to draw it to be sure.